Hello everyone, welcome to Explore Hop. So for this example, we're told that you toss a four-sided die and then flip a coin 2 times. Find the probability of having one tail and one head given that the last coin toss is a head. Let's first start by defining the following events. So let's let event A be equal to the event that there is at least one tail and one head. And we'll let event B be the event that the last coin toss is a head. Now let's create a tree diagram to visualize all possible outcomes. So here's what the tree diagram looks like. So here is the tree diagram. From here, we can determine the sample space of this experiment by listing all possible outcomes in our tree diagram. So the sample space is therefore the set containing the outcomes 1 heads heads, 1 heads tails, 1 tails heads, 1 tails tails, 2 heads heads, 2 heads tails, 2 tails heads, 2 tails tails, 3 heads heads, 3 heads tails, 3 tails heads, 3 tails tails, 4 heads heads, 4 heads tails, 4 tails heads, and 4 tails tails. Now from the sample space, we see that there are 16 possible outcomes in total. So there are 16 possible outcomes. Now, in order to find the probability of having one tail and one head, given that the last coin toss is a head, we want to find the conditional probability of A given B. So now we want to find the probability of A given B. So to do this, we can start with the following formula. So the probability of the intersection of event A and B is equal to the probability of A given B times the probability of B. So we need to first find the probability of event B, which is the probability that the last coin toss is a head, and the probability of the intersection of A and B. Let's first start by finding the probability of the intersection of event A and B. So the probability of the intersection of event A and B is equal to the total number of outcomes that have one tail and one head, where the last coin toss is a head, divided by the total number of outcomes. We can see from the sample space that the intersection of event A and B contains these outcomes. So the intersection of event A and B contains the following 4 outcomes, which means that the probability of the intersection of event A and B is equal to 4 divided by the total number of possible outcomes, which is 16. And this is equal to 1 over 4. Likewise, to find the probability of event B, which is the probability that the last coin toss is a head, we take the number of outcomes where the last coin toss is a head and divide it by the total number of outcomes in the sample space. So from the sample space, we see that event B contains these outcomes. So these are the outcomes in event B. And we see that there are 8 outcomes in event B, which means that the probability of event B is equal to 8 over 16, which is equal to 1 over 2. And therefore, the probability of event A given event B is equal to the probability of the intersection of A and B divided by the probability of event B, which is equal to 1 over 4 divided by 1 over 2, which is equal to 2 over 4, which is equal to 1/2. And that gives us the probability that there is one tail and one head, given that the last coin toss is a head. And that's it for this example. Thank you for joining us. See you in the next lesson.